Good evening, everyone. You can hear me? One second, let me see the chats.
Okay, thank you.
Okay. I think we can start. So, how was your weekend, everyone? Hope you worked on the use cases a bit. Any use case we can discuss for 5 minutes by the time people join. So you thought about IoT in the weekend or not at all? You can answer that, right? Oh, good. I'm getting some answers. Manjunata, IT solution for automatic cattle feeder. Issue no one to notice when the auto feeder malfunctions. Okay. Monitoring the auto feeder, monitoring whether all the animals in the cattle are eating, how much they are eating, monitoring the condition and availability of the food. Okay. Deliverables, data from cattle, auto feed, fodder, alert from alert when auto feeder malfunctions. Some animal have trouble, fodder is limited or fodder gone, bad smell. Specification, only registered animal are monitored, limited when checking if the fodder is bad. See, for the deliverables and for the specification, you have to go for the solution part. Your requirement is all your problems, what all you will take. Deliverables is sometimes the points are good, and specification is something where you will talk about the device or the architecture which you will follow, like data from cattle, how you will collect the data from cattle. So you will put some trackers on the cattle, or so for the cattle scenario, we have something like collars. Okay, so in the collar, we have like your phone has an accelerometer and a gyroscope, and like your watch has a temperature. Your watch also has a accelerometer gyroscope if you are wearing a smartwatch. Hello, my audio is not available. Not able to hear me. Just a second. Let me see. It's audible. Okay, fine. Okay. So what I was telling, that for the use case which we were seeing, so Manjunatha has given a very good use case, is the cattle auto feeder. Okay, so there's a in everywhere you will see in big cattle farms, we have auto feeder for cattle to feed, and there's a fodder has been put in the feeder, and automatically from time dependent way, automatically the fodder is being transferred to the places where cattle can eat. Okay, so that is what happens. Now, the problem which he has identified very good, Manjunatha, you have identified it very nicely. So that's half the battle won, I will always say. So it is something like your auto feeder alert when it is malfunctioning. Then there's another thing like the foul smell, that is the fodder has gone bad. Yeah, and some animal have trouble, the fodder is limited. So animal has trouble, that's a different use case. If you are only looking at auto feeder, you are only looking at auto feeder, because there are a number of other issues in the farm which you can address. But let's concentrate on the auto feeder automation or the IoTification of the auto feeder. Everybody is getting it, what I'm telling? You're able to understand, right? We have a cattle auto feeder where we are putting the fodder, and it is delivering the fodder to the cattle. Okay. Now the problem is that the auto feeder can malfunction, then how much the fodder has been eaten by the cattle, that also has to be monitored. And if the fodder has gone bad, then also we need to detect it, right? This is our problem statement. So what we will do is, for the malfunctioning thing, what we can do is there will be some definitely a motor or a rotor craft, a rotor setup in the auto feeder. So we will put some sensors, some rotary sensors in the rotor, and will detect that the rotor is rotating properly or not. At a particular speed it should rotate, it is rotating at that particular speed or not. So it will be something like we will have some kind of RPM detection setup. RPM is your rotation per minute setup. We'll do some sensors there and we'll connect it to our device, which can register the speed at which it is going. Okay, now second thing is regarding the smell. So we can have some VOC sensors. VOC is volatile organic compound. That is when you have foul smell, normally it is, we can detect it through a VOC sensor, or let's say it can be ethylene or methane sensors also. But VOC is a very common air quality sensor. So we can have that sensor connected at the top of the feeder line, where we get that if the fodder goes bad, it will have that smell, and we can understand from that. Okay, so we have put two things. One, we have for the rotor part of the feeder, we have put a RPM sensor, and for the foul smell, we have put a VOC sensor. VOC, that is, VOC stands for volatile organic compound. Okay, these two sensors we can put so that it can measure the air quality, and from that we can understand how much the fodder is. Has the fodder gone bad or not? Okay. Now the third thing is we can put a load sensor. Load sensor is to measure the weight. So we can put a load sensor. So I will just make a note. Just a second. I will put a note here. So we will put a load sensor. In the load sensor, we will put. Just a second. 1 second. Just a second. Okay, so in the load sensor, what we will be detecting? We'll be detecting the load of the feeder line. So now, depending on that load, we'll understand that how much fodder has been, because we know the amount of fodder which has been supplied by the rotor, and we'll know that how much is the weight of the feed line. So whenever the weight reduces, we will switch on the rotor so that there's a continuous flow of fodder. Now the problem is that if, and from the load changing, we can understand how much fodder has been eaten by the cattle itself. So what all we put a RPM sensor. RPM sensor is the first thing. Oh, wait. First we put the RPM sensor. RPM sensor. You know what is RPM, right, everyone? You know what is RPM sensor? Rotation per minute. Okay. So for that rotor, we will have some specified RPM. Like we were doing it in some cooling setup recently. So there the RPM of the rotor should be around 250, between 230 to 270, and 250 is the ideal one. So we were just detecting it. So I'm just giving it example from there. Then we have a VOC sensor, or air quality. See, Dheeraj, nice question, but the problem is, even though if it is revolution or rotation, there will be a rotor somewhere. So it will be something like you have seen your what you say, like something like your what to say, something like your wheat mills you have seen. You have one rotor at one side, one rotor at the other side. There will be a arrangement like that. Okay, so because of that, you will have somewhere a motor. Even if it's for revolution, there will be a motor. It's clear for you, or I should explain it more or draw it maybe? It will be like a little out of context for here. Just you believe me that there will be a motor. Okay. Okay. Thank you. You have understood. So VOC air quality, and then third we were looking at load cell. Load cell is for weight measurement. Load cell is for weight measurement. Load cell, and we will automate the load cell with the RPM. So whenever the load is low, load cell is lesser than what is required, we'll switch on the motor and we'll maintain the RPM. We'll check out the RPM is proper or not. And with the load cell, we'll see, we'll understand how much consumption is happening, at what time it is happening. So we'll have a lot of data regarding the auto cattle feed. So these three things we'll put as sensors. We'll have a central controller. All these sensors can be attached to a single microcontroller device, and that can be connected to internet through 4G or Wi-Fi or things like that. Okay, I think Manjunatha, you are happy with the solution, or you need something more fancy? Or anyone wants to add anything in this? You're most welcome. Thank you. Okay. It is more than your expectation or just matching your expectation, Manjunatha? Okay. Okay. So let's look into. So now today let's look into the communication part. So because one of the main portions of IoT, I will not go to the pages directly. I will just go like this. I think that's more than enough for you to see. So this is a very heavy term, OSI layer. Anyone have heard it before? Anyone from the communication branch? Or even IT? You can write yes or no. Yes, you have heard about it. So if I'm telling something wrong, let me know. Huh? I'm not very fine with it. I'm not very used to it. Okay. Okay, Divya. Okay. Shayad, you have, you know about it. Good. Computer networks. Yeah. So any wireless or any internet level network, we have this layers. Okay. So this 7, 2, and 1 is your data link. Data link and the physical part. So physical part is normally the wireless, and data link is normally your like LoRa, Wi-Fi. I'll just open this so that I can write down, and you guys also have this as a part. Okay. So wireless networks are like, you can say your data link can be Wi-Fi, Ethernet. Okay. Then it can be LoRa. Okay. Then it can be, let's say, Zigbee. So these are all, if you are wireless, if you are internet based, Wi-Fi, Ethernet is internet based, then we can write Bluetooth. These are all come under data link. Physical layer is wireless. So it's like 2.4 gigahertz, sub gigahertz, like that. Okay. Clear? Learning network concepts are in masters. Good, good, good. What is work of LoRa? LoRa is low power networks. They are okay. They are in sub gigahertz, and they are used for very high. See, sub gigahertz here means your Wi-Fi, your Bluetooth works on 2.4 gigahertz or 5.2 gigahertz. Okay, but there is another low level sensor level communication which is happening now, which is called sub gigahertz. Sub gigahertz means just a second. Sub gigahertz means it's less than 1 gigahertz. Okay. Earlier, what used to happen in this sub gigahertz range, your TV used to work with antenna and all. But now the analog TV is gone, so sub gigahertz is free. So government is issuing it for different low power, long range, low data networks. Okay, that you can call LoRa as. You have example of LoRa for that. Then we have NB-IoT. Okay, then we have Sigfox. These are some names of networks, sub-gigahertz networks. They are mainly used for sensor-based communication because they are having very less bandwidth. Bandwidth is very less. So it's in KBs or sometimes in bytes also. So you can only transfer sensor level data, just high, low, or just a value. Clear? Nikhil, I'm clear with this. You can go ahead and read about it. You will understand more. I'm touching everything so that you have a gist of all the things which are there in IoT. And then depending on your interest, depending on your field, you can go ahead and look into different setups according. Okay. So this was your media layer. Then we have the second layer as IP layer. IP layer is your packet creation routing. Normally, if you see in your system, you have 192.168 0 dot something or 1 dot something. So that is your IP. Okay, that's the IP part. Then the transportation is your TCP. So you have here TCP. So they are TCP also, UDP also. We'll go into TCP, UDP differentiation a little later. So that is their transport layer and session. These two things are taken by TCP. Then TLC is your encryption and all. And then is your application layer. Application layer is where we will be interested in. We have understood this pyramid in a generic way. I'm not going deep into it, but generally what is there? You have the wireless chip, you have the wireless protocol like Bluetooth, Wi-Fi, and things like that. Then you have the network IP. Okay, that is your IP address. Then you have transport layers like which way you will be communicating. We'll go into TCP and there's another one UDP. We'll go into that. TSL is your encryption. And application is where your main protocols, the application layer protocols like HTTP, MQTT, and things like that will work. So our major concern is in the 7th point. Rest all is taken care by mostly in the hardware section only. We don't have to worry about it. TCP we work a bit, but on top of it we always write application layer, so we don't need to look into that for now. If you're interested, definitely you can go deep and work on the physical layer and data link layer also. They are very nice things to work around on. They have stacks. Full code stacks are there. You can change that. You can read that. Bluetooth, Wi-Fi. They are very nice embedded work actually. Basic idea clear? Basic idea. Communication layers hote kya hai? What are communication layers? You can say yes or no. I'm not seeing any messages. Nobody is able to understand what, or I'm not audible. Okay. Now I can see some yeses. Ayush, Zaina. Thank you. There are 2-3 people who have understood. That's fine. Not an issue. Okay. So this was your communication layer. So this is how your full communication stacks work. You have a physical wireless or physical local LAN. You have data link. Then let's see. We'll go for the next one. Okay, so here we'll have differentiation between two things. That is your TCP and second one is your UDP. So TCP is something which is your transmission control protocol. Transmission control protocol is you talk one-on-one. Okay, so there is no broadcasting happening. You are talking one-on-one. You send a message. You get you send a sync signal, you get a sync acknowledgement, then again you send acknowledgement. So it's a one-to-one communication in a big way. Now we have another one as UDP, which is on the broadcasting system or a multicasting system, that there is a continuous request and response happening. Request and response, we'll go into that in a next slides. We'll understand that. So this one is like your request and response. Okay, you send request, you get a response. You send request, so it's in a big way. Request can be many, clients can be many, server can be single point. It's like your ball and socket arrangement kind of a scenario. Okay, spoke and wheel. Sorry, spoke and hub model. It is actually, so it's a broadcast and multicast scenario. You can see this is your server. Orange color is your server. Here it can only talk to one, but in a broadcast to one to all and one to several. Okay, not all but several, particularly UDP. Okay. Okay. So yeah. Yes, Sanjay, UDP is user diagram protocol. Sorry, user datagram protocol. Okay. User datagram protocol. I'll write it again, just for everyone. User datagram protocol. Okay. And your TCP stands for, one second. Yeah. TCP, they're all capital. I'm not doing it fair. UDP and TCP. TCP is your transmission control protocol. So it's a control transmission which is happening here. Okay. So there are two kinds. Now, okay, now there is a quiz. You tell me, I will give you 3 points. You have to tell me which one is what. Okay. Video call. Video call, which you do on your, let's say, Skype, or as we are doing in Zoom. And let's say YouTube, and let's say when you open a website. And okay, 3 scenarios. One more, or okay, you can say WhatsApp. WhatsApp chat, should I include in this? No, WhatsApp chat is fine. We'll take it on a different level. These are very common things. Now you tell me which one is. Video call is what? It should be unicast or it should be multicast? Okay, I will not say multicast. I will say TCP or UDP. Video call is UDP, multicast. Okay. No, but we can have a video call one-to-one also. But then also you need UDP for that. Or UDP is better for that. YouTube will be UDP. On open a website, UDP only. Okay. So video call is UDP. YouTube is UDP. Open a website is UDP. Let's say I'm saying it's not about broadcast and multicast. If you think about, no. Open a website is TCP. What is happening here? See, TCP and UDP, what is the difference basically is from the user point of view, because we always think from the user point of view when we are designing an IoT system. So TCP takes care. It can be late because you are sending some request, you are getting acknowledgement that you have sent the request, then you are getting the value, you are sending acknowledgement, then only the full setup is done. So it is a very time taking compared to UDP. It is time taking. TCP is time taking. So because of this time taking, it makes sure that you get the full data, but there will be a time delay. So if I am doing a video call and there is a time delay, it will be more problematic than if I'm in UDP. What will happen? Some packets will be skipped, but you will get a real-time data. So wherever you are looking at a real-time scenario, UDP is always preferred over TCP. And wherever you are looking at a time TCP for whenever you are more concerned about the data loss, then you will go for TCP. Like your open website. When you are opening a website, you need the full website, right? Half of the website is open, half of the is not open. It's not because it's not a real-time data. It's somewhere it's stored and you are just seeing it. Okay, so depending on the use case, we select UDP and TCP. Mainly on the communication part, video, audio, then messaging, your YouTube, your WhatsApp messaging and all. We normally go for UDP on that. There is a mix and match also. On TCP also, we have some protocols where we do it in a different way. Okay, can you give me some more examples where we can go for UDP and TCP? Anyone? Can you give me an example? Anyone? You do that over your phone, you use that. Give me an example, simple wala. TCP WhatsApp chat. Yeah, TCP WhatsApp chat and all are a little complex. We'll go into that. They use TCP also at its bottom, but their top layer, they are using something different. Skype is UDP, definitely. Video calls are always UDP because you always see that you don't see the older picture. Even if when you stream, you see real life matches, the screen stops for some time and then again restarts at the new frame only. Something UDP should be used to avoid data losses. No data losses when you are trying to save, you have to go for TCP. So downloading something is always TCP. Okay, UDP in phone calls. Yeah, you are not giving me the good example. So you, how many of you play online games? Your and multi-user games? Something like PUBG. It has to be TCP or UDP. PUBG will be TCP or UDP. Yes. Think about, you are trying to download the screen where your enemy is, and by the time you get the download, the enemy shoots you. TCP, email. Yeah, email will be TCP. PUBG is TCP. No, no, no. PUBG is UDP. You need real time, right? In PUBG, you need real time video. You can lose some frames, that's okay, but you want the latest one. See, where time, real time is the essence, you go for UDP. Where data is the essence, you go for TCP. Clear, everyone? Okay. Whether Gmail comes under TCP, yes. Email always comes under TCP. You don't get, see, when your real emails are not real time, right? Somebody sending you, you will get it after 1 minute. That's okay. Someone sends you, you get it after 1 minute. Real time here means less than a second. That is real time. The refresh rate is less than a second. In some cases, in videos and all, it's in milliseconds, 50 milliseconds or maybe 10 milliseconds. If not every game, multi user games which are there, we are playing online, then it will be UDP only. So there are some setups in. So I will just name that. I will not go into that. If you want, you can look into that and understand. So there's a thing called WebSocket. For websites with real-time data. They work in a UDP manner. Okay. Media television is UDP. Yeah, media mostly is UDP. Live news and all is mostly UDP. Okay. They are mixed also. I'm just telling about from the, there are a lot of, because TCP was very old. Okay. UDP is not that old. So what happened? People have designed different protocols over the TCP stack itself. Okay, which behaves like UDP. And nowadays they are changing. So one of the major protocol which we will be using for IoT, which is very popular, that's called MQTT. MQTT is actually a real-time communication thing. We'll go about that later. Okay, we'll discuss it when it comes. Okay, sure. Let's see. Okay. So now we have two methods here. One is called communication methods. Two-way we communicate normally. Sir, your voice is very low. Now it's fine. I can't go away from the mic actually. Now it's okay. I will see if I can increase the mic sound. Let me see. Now it's better. Time before. If anyone can message. Okay. Thank you. So what happens? We have two communication methods. One is we talked about the TCP UDP. TCP UDP is not your application final. So it is mainly your session and transport. How you transport a data or the thing, it is for that. This is how you behave while communicating. So you can see there is a newspaper published. There's a newspaper guy and there's a person who is reading the newspaper. All of you can see it. So can you give me a hint what publish and subscribe should be? We will be very much interested in publish subscribe because of IoT has a very good base on it. Anyone? I'm audible, I think. Okay. Okay. I will give you an example. So what is publish subscribe? So there are two methods. One, the second method also I will show you. This is your request response. This is what happens when you go to a restaurant. And this is what happens when you take a newspaper. So what is the procedure of taking a newspaper? What is the first thing? Let's say you shifted to a new place and you want to get the newspaper from next day. What you will do? Anyone? First thing, what you will do to get the newspaper from next morning? Anyone? Subscribe to the newspaper. Okay, definitely. And then what will happen? Whenever the newspaper is published, you will receive it at home. And there will be a person in between who will take care from the publication to your place, delivery, right? So PubSub model works in that way only. So there are two. PubSub model is working like a. I will just go to this page. I will show you. Okay. No, I will not go there quickly. So what is happening? Publish subscribe model works in a way whenever you normally subscribe. Let's say we will go for not newspaper, we will go for data. Newspaper is published, but the reader reading it when we have to subscribe. Yeah. Subscription in a publish subscribe method, the subscription happens before publication. Let's say if you subscribe today evening for the newspaper, you will get the next subscription. You will not publication. You will not get today's publication, right? Same way. So you have to always subscribe beforehand. Whenever there is a publication, you will get it. That's how it works. So now I will give you an example. Let's say you have there's one data source which is publishing the data, and rest all data sources are waiting for that data. Waiting for that data in the sense they have subscribed to that data. Whenever that data comes in, they get the data. So that is how this publish subscribe works. We'll go into that in a deeper way later. So if we say, let's say we have okay. In the publish subscribe scenario, let's say we have subscribers will call it as client one, subscriber and publication, both publisher we will call as clients. So we have, this is our publisher. Okay. This publisher is client one, and we have and there are two clients, client two. Now we have subscribers as client 3 and client 4. Okay. Now there has to be someone in between to deliver the subscriber the published material. That is the newspaper wala. In newspaper wala, in normal publish subscribe model, we call them as broker. It's like when you go for seeing the, sir, you can increase the font. Let me see if I can do that. Font, no. I'm not going to do this. We are not able to. Wait, just a second. Give me a second. Just a second. Let me see if I can increase the font. There will be definitely some way to do that. Yes. Here it is. Preferences. Font and color. I will use. Then increase it to, let's say, a bit more. 20 will be good, I think. Yeah, this is okay. This is okay. No issues. No need to zoom. So now, if I go here, I can see the broker. There will be one broker, will always be one. There cannot be more than one broker between pubs. So what is happening here? Whenever, okay. So whenever the publisher, client one or client two, anyone publishes something, it comes to the broker. Okay. And the broker sees who have subscribed. So let's say this client will have some topic to which it will publish. It will have some topic, right? Otherwise, how it can publish something? These are this is called topic. Let's say this is topic one, this is topic two. Now, these clients will be subscribing to these topics. Let's say this client one has subscribed to topic one, topic one, and this client four has subscribed to both the topics, let's say, because you can subscribe to multiple topics. Topic one, comma, topic two. Okay. They've subscribed to both the topics. Now, and broker is in the middle. I should write it like this. I should write it like this. Broker is in the middle. Okay. Yes. See, this is the same example you have for your land. If you go for rent houses, you have the same concept. Broker will know the party who's giving the landowner or the house owner, flat owner, and he will know the tenant also. So he will connect both of them depending on the requirements. Okay. So now what has happened? The subscriber client 3 has subscribed to topic 1. Client 4 has subscribed to topic 2. Now the publisher, there are two publisher, client 1 and client 2. They are publishing on topic 1 and topic 2. Now let's say this one publishes. Is published. Some message is published. Okay. Who all will get it? Client 3 or client 4. Who will get it? You can write down. Who will get the message? Both will get the message. And let's say Divya both, Karishma both, all of you are sure both? Whoever subscribed. Yeah, that's a common thing. So whoever subscribed, client 3 and client 4 both have subscribed. Okay. So there are few things which you have to always remember. Subscription has to be done before publication. Otherwise, you will miss that data. Both will receive. Yeah, that's true. Now, let's say the second one publishes. Now, who will get? Client 4 will get. Only client 4 will get. Client 1, 3 will not get it. Right. Exactly right. So this is your simple publish subscribe model. So you think now in IoT case, okay, when you have a sensor device, okay, and you have your, let's say you have sensor 1. See here, if I'm saying sensor 1, it's not only the sensor, it's the full setup, which is sensing and sending it as a client. So it is a client. Sensor 1 is a client and it is a publisher, because or it should be a subscriber. Sensor should be a subscriber, right? Or it should be a publisher. A sensing unit. It's a sensing unit fully. So it is subscriber or a publisher. Just think an answer. A sensor should be a subscriber or a publisher. Manjunatha, publisher, why? If you're saying publisher, tell why. If you're saying subscriber, tell why. Anyone else? Publisher, sensor gathers data and send it. So it's like publishing data. Nice, nice. Okay. And if I have a, let's say, a actuator, which is like, if I have a sense, so here I have a actuator. Subscribe because he is recipient. And since it's input, yes. So you had Muskin exactly right. So actuator is a actuator one, I will write. So actuator one is also a client. Both are client, but sensing devices are always publisher. And actuators are always subscriber, because actuators are waiting for, let's say there's a motor is waiting for an input that you have to tell it to be switched on or switched off, or run at a higher speed or a lower speed. So it doesn't know, it doesn't create data, it only follows. Actuator always follows and a sensor always creates. Okay, you can compare the sensor actuator with your eyes and your hands. Your eyes can see the data, so it is publishing it to the brain, and the brain is sending a particular topic to your hand what to do. Interesting, right? Publish subscribe method. So whenever we have a sensor actuation system, mostly we'll go for pub sub kind of a scenario. Mostly. There are some cases where we will not go for it, but in most cases we will go for that. Okay. Now let's say, so a question, can a single setup become a client as well as a subscriber? Sorry, a publisher as well as a subscriber? Any idea? It can be a wild guess, yes or no, you can say. A single client can become, see, technically it will be two clients inside one device. If, but that client can be there, which can subscribe as well as publish. No, client can be one only. Yeah, one client can do both the things. No, it should not do it. No, in MQTT or in published scenarios, no idea. Yeah, that's natural. We have not discussed that much, but see, in a client scenario, a client can be publisher, subscriber, or both together. It can subscribe to something and continuously publish. Whenever it gets that new data, it publishes again something depending on that. Okay, so you think about your kind of your gateway. Okay, now you have, let's say, device one, which is your, I'm giving you examples. Here, your device one, which is, let's say, a motor. And you have a device two, which is a sensor. Now we have a gateway, which connects to both device one and device two. And it is also a client. So device one is also a client, device two is also a client, gateway is also a client. What gateway does here is, gateway does, so here we have two sensors, let's say, not one. Let's say we have device 3, which is again a sensor. So taking data from device 2 and device 3, depending on the data from device 2 and device 3, device 1 has to be instructed what to do. So this gateway subscribes to sensor device, I will write D1 and D2, and it publishes to, sorry, subscribes to D2 and D3, and it publishes to D1 what to do. So this gateway becomes like your edge device. Edge device is something where it is processing. There's some logic which is there maybe, or some settings which are there, which are sent to it, or which is told to it, and it, depending on that setting, it works around. We'll discuss about these real-time scenarios. Okay, so in this case, the gateway client is also a subscriber as well as a publisher. Agree to me? Understood what I said? Now it's clear that we can have a publisher subscriber, but there are special cases normally. And sometimes it's not necessary that the PubSub is included. In your single device can have some motors and can have some sensors together. And they all, depending on their topics, they can publish to different places. Okay. So only the topic changes. And a single client can subscribe to multiple topics and publish to multiple topics. The logic can work around. Okay. Clear? Sure. Good. Now let us go back to subscribe method. Sorry. Request response. Now let us look into request response model. So what is the request response model? Anyone? request response is something like when you go to a restaurant and you order food. So what you do is you have a particular menu. Menu here can be said as, I will use some out of the world examples for you. Okay, so you will have a menu and you will request, right? You will request for food. We'll request what we need and our needs are provided. Request and response will be from the waiter side. Waiter side or from the owner side, they will give you food accordingly. Okay. So request response is something like your when you call for a website. And if I talk from, sorry, I was away from mic. Yeah, if we go for let's say a website call. So what happens whenever you call a website? This is a request you are making to the web browser and the server gives you back, yeah, client server model. So yeah, client server model is server. Wherever you say server, the server responds. So it serves you. Okay, client is something who will ask for, who will request. In the sub pub model, what happens? There's a broker and there's a clients. Here you have a server and a client. Client request, server response. Okay. So this is normally where I will give you an example for the first one. First one, we will give an example like we have something called for PubSub model. We will, there are other PubSub models also, huh? But for now, for our scenario, we'll use MQTT. MQTT is MQ Telemetry Transport Protocol. In short, they are called, now nobody uses the full form, but earlier it was called MQ. TT was telemetry transport. MQ was a kind of sensors which were there and people were putting them in Middle East somewhere. So it is around in 90s, this protocol was evolved for a very low setup. When you have a very low bandwidth and your payload is what your data size was very low. Okay. So protocol, it is for protocol. Wait, protocol. Now it is very low payload. Okay. And bandwidth is very low. Okay. We use this MQTT protocol. And for, let's say, for request response, can anybody give an example? Anyone? Any example? Request response, what can be the example? You all use it when you are online food. No, I'm not asking for, I'm asking for the protocol name. You all have used it. Whenever you write a web page, you start that with that. Yes, HTTP. Sorry. Okay. So HTTP is one of the major examples. HTTP as well as S also is one of the major examples which we can take from this. Apart from that, there is another kind of protocoling which is your streaming. We stream normally your VoIP is your voice over internet or voice calls. FTP is also a request response protocol. Even as SMTP is also a protocol which can be traced back. It's that. Okay, so I will not go into this type of protocols. HTTP is good enough for us for some cases in IoT. HTTP is very good, useful when you have a heavy amount of data and you want that data to be sent properly and no data to be lost. Okay, and it's like some time interval where you have that data part. So normally we use that also sometimes. Okay. Okay, so let's look into an example here. We already gone through this example. Here we'll just talk about a MQTT broker. We will talk about a MQTT broker and client. We have already discussed this. So in here, I will just discuss it from the MQTT point of view. We have discussed it from a general point of view. We'll discuss it from the MQTT point of view. What is that? If I say MQTT, what will be the difference? So MQTT has a MQTT broker. We have clients. Now, give me an example. I'm just giving you a rough case. Okay. We have one sensor device which can publish data, that is publish, and we have a app which shows this data. You might have seen this kind of apps, some sensor, and you are seeing the temperature or the humidity or something like that. So what this app is a client here. What it is? Sensor is a client. We have already discussed it. What this app will be, or let's say you have a web page where you can see some data. What is that? Anyone? This app will be what? Just a second. Not exactly weather app. I want, let's say, a body temperature app. You have a sensor based thermometer, and whenever you put it, you see the data in an app. How it will be? What it will be? It will be a client, or it will be something else. Thermometer. Yeah, thermometer. Thermometer is fine. No, sorry. Wrong. Oh, the full bitmap has come. Wait. Anyone? Let me show you this. Something like this. You can see you have this is your device and this is your app. Okay, now what all of you can see it. It will be a client. It acts like server for show data. Okay, let us see. Thermometer client. Any other answer? One has told me server, that is Harshal, and Vasantha has told me it's a client. It's a subscriber, or if it's a client, it's subscriber or publisher. When it will be publisher, when it can be subscriber. Anyone? Just a thought. What we are saying? We are saying app is a client or a server. Subscriber when it consumes data. Yeah, subscriber. Okay. Yeah, okay. Let me close this up. Yeah, it's a app is a client. It can be a subscriber as well as it can be a publisher. Example, I will give you a home automation example. In home automation, you have a temperature sensor connected to the internet where the broker runs, and you have a light, or I should say fan, which is also connected, a smart fan and a smart temperature sensor. So they both are connected to internet. So here what will happen, the app to control or know it will, for fan control, it will be a publisher. For sensor data display, it will be a subscriber. Okay, clear everyone? Clear? Any doubts? You can say yes, no, so that I can understand. No doubt. Good. Good, good, good. Yes, sir. You have understood. That's good. So this is something which is very confusing if you normally look for any architect who is trying to architect any solution. The subscriber publisher principle should be very clear with you. Okay, so that is fine. So now in the second half of today's class, we'll go for one demo where we will put up. I will put up a device which is connected to a sensor which is giving temperature, humidity, and pressure, and we will just display the temperature, humidity, pressure on the terminal on my desktop. And maybe if time permits, we'll write a pops up client also in for that. Or otherwise, if it doesn't, then we'll go for that in the next class. Okay. So I think we will take a 10 minutes break as it's already 7. So we'll meet at 7:10. Okay, everyone. Okay. So we will be back. I should write this big way. Back at 7:10. Okay. I should write PM, otherwise people can come in the morning. Okay, not a problem. Okay. Thank you, everyone. Yeah. Hello, everyone. Everyone is back, I think. Hello, everyone. Everyone is back, I think. I have to mute myself. Yeah. Now I'm audible. I'm audible now, everyone. Okay. So let me do one thing here. You all can see this kit. We'll do the connection first, and then I will come out of it and we'll go for my laptop display directly. Okay. Fine. So here what I'm using here is the main board, if you can see. The main board here is called ESP32 Node MCU. It is called ESP32 Node MCU. Node MCU is the board name and ESP32 is the chip name. Okay. The IC is called, this is the IC and this is the full module. This is the full module. Okay. Okay. This is called SOC. SOC stands for System on Chip. So here we have in this small chip, you can see the silver part of it. The silver part. Everyone can see that. Yeah. So this is nothing but a microcontroller. How many of you seen this before or you have it already? Anyone? Anyone has it or have seen it before or used it before? You can type, right? Please type so that I can understand. I can't see your faces, so I cannot understand from that. No, sir. I have seen.
Hello.
Yeah, yeah, Amar.
The problem is that now they are only able to see the PPT, whatever you are showing.
Okay.
Not
Wait,
able to see the key.
yeah, I will not stop sharing that concept.
Just stop screen sharing once.
Yeah. Now it's okay.
Guys, they are able to see. As a host, it's visible to me, but I'm not able to check from user end.
I think this one I have done this already. I have shared. No, I don't know that it will be shared or not because I'm having the video. Anyone can see the video?
No. You need to share a screen from that device as well because you are showing from camera, no? It's not visible for us.
Okay. Just a second. No?
Just share the screen from the same device.
Okay, everyone can see this now?
No, nothing.
Nothing. Shared my screen, but Jesus. Just a second, everyone. If I start a video, I think they should be able to see my video now.
It's Anirban, another Anirban. You will be able to see it, I think.
If I'm sharing the screen, I'm not able to get. Wait, what to do? Someone, you need to help me on this. If I'm sharing, if I'm sharing my screen, I'm not getting the camera. It is going out of sharing because I think video camera cannot be shared. Okay.
Yeah, guys, I think now it's visible to you. The kit.
If you can go to the co-host, I think they
Yes,
can.
it's
they can
visible.
see. It's visible, right?
Yes.
So can we check out the chat?
No, it's not visible. Okay.
How should I do this?
मैं बैठ गई
Not able to do this.
You are.
And then just unmute your cell phones as I muted all the participants as they are muting. Guys, we are able to see the screen wherever we are showing the kit.
Visible now.
Yes, few of saying yes, few of saying no. But I also joined as a user in, so it's showing to me.
Okay, fine. So, what we are using, I'm just writing it down here. We are using ESP32 node MCU.
Pin your screen. How I can pin my screen? Amar, can you pin my screen?
Yeah, I already pinned that.
Okay. So we have this ESP32 and so it is having a microcontroller as well as a Wi-Fi radio. Both things are together, okay, in a single chip. So earlier we used to get microcontrollers separately and Wi-Fi radios and Wi-Fi wireless chips separately. So now we have this, and now there are a lot many variants of these where we have a single chip which acts both as a microcontroller and has a Wi-Fi radio inside it. Okay. So now what we have added to this, we have added to this a BME 280. One second. BME 280 sensor. This is temperature, humidity, and pressure. All three together. Air pressure. Okay, I will show you the sensor. This is the sensor. Okay. You can see the silver thing on the PCB. You can see the silver part.
This is very small. This is the thing, this part, very small. It is around 1.5 centimeter to 1.5 centimeter of this one. These are called MEMS, MEMS. You just search around what is MEMS. Okay, you will understand. These are very small sensors. So these are all used in automobiles, in air conditioning. Sir, I'm not getting your screen. Okay, this is, sir, keep it far away from, yeah, you can see it now. There's a hole, and in front, in next to that, Aman Kashyap, please. Yes, sir. Yeah, they have spotlighted my video, so you can see that now. So this is your sensor. This is very small. You can see my hand. It is very small. The circuit itself is very small, and on that, if you see that silver thing, this is your temperature, humidity, and pressure sensor. Okay, so we are connecting this to the microcontroller. Okay, this microcontroller we are connecting it to. The sensor is connected to this. You can see. See, this is connected through this. Okay, this folder is connected. Now we'll do some, and it is connected to my system. So we'll do some, we'll be back. Now I'm not going to show this again. Just assume that this is connected properly. This is connected properly to this, and we'll just go for the programming now. So we'll be back to our screen. Amar, I will just stop the sharing. I think I'm not sharing anything. So I will stop my video. And I will start sharing my screen here. Wait a second. So now we have come to this. This is a platform called Arduino. How many of you have heard about Arduino till now? Anyone? Okay. Okay, I've stopped sharing. Wait, we'll share one more time. Desktop. Yeah. Yes. So now we'll have our thing here again. Okay, so it is already here. That's why you're not able to get it. Okay, so we'll write a code, nothing called Arduino. Okay. So I have my Arduino. I'm not going to tell you how to install Arduino and connect everything. That are too many articles are there. So you have to search for Arduino ESP32 BME280. If you write all these three things together, you will get a full tutorial. There are n number of tutorials which are there online. So what we will do is I'm writing a simple code. I'm clear to everyone, right? You can do that. Everyone, please tell me. Here you are. Yes, sir. So your search should be Arduino plus ESP32 plus BME280. That's it. You will get a lot of code and tutorials how to do it. I have shown you the circuit. So now let's deep dive into this. So we have some libraries installed. This is your library thing. I'm not going to tell you how the Arduino works. Okay, I will just go through the code a little bit. Code also is not related to. So we have some functions here to read pressure, read altitude, read humidity, and read temperature. Okay. You want me to increase the font? I should increase the font. Don't need to go through this. You just, because later on we'll just simulate it. Okay, just to give you a real feel of the thing, I'm doing this. Okay.
Okay, so we have some functions here: read pressure, read altitude, read humidity, read temperature, and we are just printing them together. So this is your for your upload code. This is your terminal. So I'm uploading this code. You can see the compiling section working. So this is a simple code where we are just simply writing the in the meantime, let it compile. In the meantime, I will just go through the code a little bit so that you can have a feel of it. Okay. So in Arduino, we have normally two major structures or major functions, you can say: setup and loop. Setup is whatever has to run once will be put in setup. Whatever has to run in a while one or in a infinite loop has to go inside loop. So we have two functions. One is setup, another one is loop. One is setup, another one is loop. So what we have: setup, another one is loop. Setup is only once whenever the microcontroller is switched on. Only once. Only once here means whenever the microcontroller is restarted or switched on. Okay. Loop is infinite loop. In real-time systems, infinite loops are very important. Okay. Because continuously that same task has to be done. Okay. So in the setup, we are doing the serial monitor. Serial monitor is what you see here. Wherever you will see the data is serial monitor. So we'll do some serial monitoring, begin, print something on the serial monitor. Then we'll check out the BME sensor is available or not with this function BME.begin. If it is not, we will say that we have not find a valid BME sensor. Check wiring, default testing, done. Okay. Now in the loop, what we are doing print values. Print value is the function we have written below, and delay. We have given some delay. Okay. Now in print value, what we are doing, we are running these print statements in serial monitor, and we are reading using this BME.read function. BME.read temperature, BME.read pressure, BME.read altitude, BME.read humidity. That's it. It's as simple as that. Our compilation is done. So let's go for the serial monitor and see what we are getting as a this one. Okay. You can see 30.67. This font I cannot increase. Huh? Wait, I will stop this column. Okay. So my temperature of my room is, oh, it's very hot. 30.363. Pressure is 108. I'm in Bangalore, so its pressure is little low. Altitude is 912. That's Bangalore's altitude. And humidity is 63.25. Okay. You are able to see the real-time data. But this data is from the device. It is directly publishing to the, it's not publishing serial monitor. Maybe I'm just simply printing it. It's clear to everyone? Thank you, Karishma. Yes, it is amazing. What I will do is, what we will be doing next is we'll write some code, add some code into this, where we will try to publish this somewhere. Okay. So let's check out. Amazing. Okay, it's not yet amazing. It's just the sensor data now. It's not publishing anywhere. You will get this data on your laptop or mobile later on. We'll do something like that. Okay. So here, so this is your data coming down. Okay, continuous. You can see the data, and because it is inside the loop, we are running this print value. And if it's like this delay time, if I change this delay time to, let's say, some higher value, delay time is what? Delay time I have defined somewhere. Unsigned delay time. Yeah, delay time is 1000. 1000 here means 1 second. I will just make it 5 seconds, so it will become slower. And I'm uploading this data again. So let us check. Temperature device and code each to each other. Temperature sensor is connected to the microcontroller pins. Okay, I will share with you all. I think this I will give you a simple tutorial. I will give you a simple tutorial. I'm putting a link on the. I'm putting a link because this is a very common thing. So I've just simply taken it from tutorials, which you can also go for. This is random tutorials. You can check this out. Just the same code I have written here. Okay. I'm sharing this link. This can be done. Same thing. Okay. So now you can see the temperature is coming slowly. Earlier it was in 1 second gap. Now it is coming every 5 seconds. Clear to everyone? Okay, so let us look into this. Now, what is the scenario? Are this setup can be a publisher? Okay, so let us see. We'll publish the data. I will show you the data, how that data is coming, and tomorrow next class we'll write the our own client so that this data you can see in your screen itself. Okay, so let us see where all we should put it. So first of all, we'll add a library. Just a second, let me get some direct code which I can simply show you. Okay, we'll add a library called pub sub hash include pub sub client dot h. Okay, this is for your pub sub scenario. Now we'll also add Wi-Fi dot h to it so that it connects to Wi-Fi dot h. Okay, so these are two libraries I have added. After this, let me put some. Let me put this. I will change later on, and then I will show you. Okay. So this is your SSID password. That's your Wi-Fi password. I have to put my Wi-Fi password here. I will put that later. Okay. Then we'll have a MQTT server. This is your MQTT server. Okay. This is we'll put a server name. We'll use a public broker. Public broker is something like. Wait 1 second. Paho MQTT broker public. I'm just searching for a public broker which we can get free so that we can use that as a broker is there. Let's see, we can use broker that wanted to use Eclipse broker. 1 second. Eclipse. So we will use a free broker so that you all can access that. Okay. So it becomes easier for you to get the same data at your place. Looks fascinating, or it sounds fascinating actually. I don't know. It looks fascinating till now or not. Does it? Guys, you need to tell me. See, now let me see Eclipse. We have mqtt-eclipse.org. So this is one free. This one we can use. These are free, so that means anybody can subscribe to your topic. So they are not secured, but for your use case, this is good enough. We have another one, test.mosquito.org. Mosquito is in the name of the broker. We'll use that later on. Okay, so this becomes your MQTT server. So now let's go back to our. Okay, so here we'll create a. Here we'll create another thing as we will create a Wi-Fi client and we'll pass that Wi-Fi client to the PubSub client. So if you remember when we were discussing this layer, so here you can see we have a, just a second, I will just open this for you. So here if you see in the layer, we had one layer as physical and then we had the IP and TCP and application layer. So this you can see in our code also now. You see in the code, first we are declaring a Wi-Fi client object, ESP client, and then we are passing that ESP client to the PubSub client. So ESP client, the PubSub client will communicate using internet from the Wi-Fi client or the TCP IP or the IP from the Wi-Fi client. Okay, clear? This is mostly C, C++ mix. Arduino has a C, C++ mix. So I'm not teaching you this part. Okay, I'm just showing you the code structure. When we will do the simulation, we'll do it in Python. So the code logics are similar. Okay, so if you know C and C++ basic, you can work around. It's very simple actually. It is made for people who it was actually initially made for people who could not write codes, but now it has become one of the prototyping standards for embedded industry now. At least at the prototyping, in some places it's even for this setup. We have to put setup Wi-Fi. I'm just putting some things back. Here we have to put in the setup. We have to put up this one. Yeah. We need to put setup Wi-Fi function is there, which will set up the Wi-Fi, set server MQTT. So it is connecting the client to the MQTT server, and the port normally which we use is 1883. Okay, these things will go through when we go through the Python. We have similar client library for Python also. So we can look into that also later on. And even this ESP32 works on MicroPython. If possible, I will try to showcase that code also to you later on. Okay, this I'm not going deep if I get the MicroPython thing, because I never code embedded on MicroPython. So I will just check if I can get that in the next class or so. So we'll go through that code and then the normal this one. Okay, Wi-Fi setup I will write down as a, just a second, I will write down as a code. So we had this setup, callback, setup is gone, loop is beginning. So we should have something called setup Wi-Fi. Wait 1 second. Should have a setup Wi-Fi. I have the setup. Now let us create a setup Wi-Fi function. What this function does is it just connects to the Wi-Fi directly. Okay, so setup Wi-Fi, you can see connecting to Wi-Fi, it takes the SSID and password and gives it to the Wi-Fi begin. Wi-Fi is connected and Wi-Fi is connected. After that, Wi-Fi is passed, we print the IP address and Wi-Fi.local IP, those things we do. We have a callback function here. Callback function is something I will go to latest. Just a sec. Just a second, everyone. Go through the code once. So what all we have done till now in this code, we have added some libraries, which is mainly PubSub client and Wi-Fi library, because it has to connect to internet. We'll put our SSID password here. We have a MQTT server, which is a free broker which we have used. Okay. Apart from that, we have done the Wi-Fi client. We have created a object of Wi-Fi client and we have passed it on to the PubSub client. Okay. Now, after that, what we are doing is in the setup, we have added this part setup Wi-Fi function and client set server and set callback. Callback is another function. So see here, this code works around in a way that whenever you are in a situation where you don't have the subscriber, whenever the subscription, you run a subscriber initially, and whenever there is a data published, the subscriber will initiate a callback function. So whatever we write inside the callback function will be called whenever subscription happens in that particular topic which you have subscribed. Am I clear with this? We'll go through this one more time when we go through the clients, but just the gist of it you are able to understand. We are writing a callback function. This is my callback function. So this is my callback function. So this callback function, we are doing a message has arrived on the topic. We are writing the topic name. We are writing the message. Then depending on the way, we are doing a serial print, simple serial print. We are writing, this is the output we are getting. A temperature is on, serial monitor on, high, low. We are just doing some mumbo jumbo. This is a rough code. You can write anything. If it's like the serial print also, that's good enough. This we should not do now. We'll do that later. This is this will be more confusing for you. So we're not doing that. We are simply printing. Simply serial print char that message dot I. This will give you the full message, whatever message is there. Okay. Now next is your reconnect function. We'll run one reconnect function so that whenever it is reconnecting, it will subscribe back to those. Then we have a loop inside loop. We are not doing anything before. Now we'll do a lot of things. If client inside loop. Now print values will not only print, it will publish also. Temperature, I will just publish the temperature for now. Inside loop will have another thing called client.loop so that the client is always connected. Okay, we'll write client.loop thing, and then we will do print here. For printing this, after printing this, we will just do a client dot publish. See, whatever functions you are seeing here, na, these functions are very common. The name wise, they are very common. Okay. Client dot publish. In Python also, we write it like this only almost. This is my let's say I put my name Anirban / Sensa. Okay. This is my publish topic, and what I'm publishing the BME retemp. I'm publishing it directly, or I should do temp is equal to this and putting a semicolon here, and in place of this I will write temp directly. Okay, and here I will publish temp. This should be a string. I think this should work. Okay, let me publish this. Okay, let us publish this one. This is fine. We'll publish the other things later on. Okay, let me see. We'll have a lot of errors. I hope so. It doesn't. No, wait. I have to put mine. Just a second. I will put my SSID password, and I will not show it to you guys. That's why I will just simply write my SSID password. Okay. Once I write the code, it should connect to my local network.
Okay, we are back with the code. So let me see if we can get the code done now. Some errors definitely. Wi-Fi.h is no such file. Let us put our Wi-Fi. We'll just search for Wi-Fi as a library. Hmm. Hmm. And then those things. Wait 1 second. Let me see. Still have this issue. Let's see if I comment this one. The client does not exist. Wait, I have to check out for this Wi-Fi thing. Wi-Fi.h. Well, it is not taking in Wi-Fi. Just a second, let me see if I've selected this right. Things connected. Yes, connected. Let me see. I can take it there. I don't think so. Wi-Fi library. I'm just searching for a Wi-Fi library for ESP32. Okay, online. If I have it, I will then show you how this works around. We have this as 1 second. First thing we need to Wi-Fi.h into installing ESP32. Wi-Fi.h should be there directly. Just a second, everyone. Okay, yeah, that might be true. Thank you. Yes, that might be true because Wi-Fi should be a default thing. No, wait. Should be default thing. I'm just simply copying it. So you let me see. Yes, it's Wi-Fi.h. Thank you, Rafat. Thank you, Rafat. Temp is not declared. Okay, it will be float temp. That's right. Thank you, Rafat. Karishma, what should I check? Bracket is missing. No, I tried both the things. That's okay. It was only the F. No matching called PubSub client. Okay, PubSub also I need to install. PubSub client. Yes, this is directly available. So here you can find these libraries. If they're official in the this one, then you will directly install them. Successful. Now let's see. It should compile. It's compiling. Should not get some errors. Let us see this. No, we are getting another error. What is that? No matching function called pops up client. Why? We have installed the client. Let me see.
Pops up client. I'm written something wrong here. Just let me check once because I typed it and I might have done something wrong. It's pub pub.sub.client.h.
I have installed it also. Pops up client.
Just a second.
Let's see. It's already installed. PubSub is already installed. Why it is saying it's no function except okay. Some parameter issue is there. Wait. I've written something wrong in line number. Okay. Publish. In publish, I've written something wrong. Just a second, guys. In my publish thing, it was here, right? Publish.
You have
this publish. The 4 arguments provided to PubSub client node payload. They need topic. Okay. Topic I have given. Payload, unsigned length, and Boolean retain. No, I don't want this. Constant payload, unsigned p length. Payload I have given. Boolean retain. This one. Topic I have given. Char.
okay. I have to make it a char client. Okay.
Fine, no issues. Let me make it. Here we have made it a string.
So there's some issue with this. I will just make a char temp
String. String it will be called.
Okay, so I will assign it to, let's say, 8. That's fine enough. Now, whatever it has read,
I will use one function here which converts my this thing step. Okay. Name. Temp as and this is temp. I think now it should work. Temp, and here we'll put up temp string. Temp s. Okay. So now let's see if we can publish now. I should publish now. Let's see. Hopefully, yes. No. Expected this before home. Tempest. Oh, extra bracket. Sorry. This time should
fastly do it.
okay. Meantime, let me find any free client. Utility client online. Yes. Almost there.
Let it compile.
Yes.
It is compiling. Yes. And let's go to the serial monitor. Connecting to Frugal Home. Yeah, it is publishing. It has got its IP address. It has connected to my home, and it is now publishing most probably. So, our this one was what? MQTT eclipse.org, right? MQTT eclipse.org. This we don't have. Okay. And so we have two things here. One is your, this one is MQTT dot eclipse dot, wait 1 second. Let me go for any other one. That is your IoT eclipse.org. Okay. Let me see if that works. IoT.eclipse.org. Wait 1 second. IoT, MQTT IoT. This one I'm trying to use now because I have a reader for this, and my topic is, the topic I'm publishing to is what it is. Let me see. Topic is ESP32 output. No, this is subscription. I don't want subscription. Mine is Anirban sensor. I'm publishing to Anirban sensor. Okay. It's uploading to the new one. Trying to connect. Connecting to Frugal Labs home. It's connected. It has got the IP connection error here. This side I'm getting. On my this one. Any other I can do? Mosquito.org I can do. I have this client page. You can see this. This is a client page where we can go for, this one is not connecting. I can go for this test MQTT mosquito.org also. But let me see first it connects or not. Then only I will try. Yeah, this connects. So test.mosquito.org. Okay, no issues. We can change this up every time we want. We are changing this to test dot test dot mosquito.org. Okay. We are uploading new code where we have changed this. Now let us look into this one where Anirban sensors. Okay. So our topic is subscribe to Anirban slash sensor. Sensor or sensors it was. Just let me have a check. Subscribe to publish to Anirban sensors. Okay. Sensor. I have does this. Let me see if I get some data. I've subscribed to this. I should get messages here. Just a second. Please provide a topic filter. Okay. Close. Let me. Confirm. Topic filter is getting a message here. I'm publishing client.publish, and this is under void loop. Okay. Reading the data, it is printing all the data, and it is client.publish. Anirban sensor, and my topic is this one. I'm able to connect properly. You have to be a little patient for this. Test.mosquito QUITTO. Yes, this looks okay. Fine, no issues. We'll start up next class where I will do this setup fully for you. And I will give you one, I will show you one client also where we can get this. I think I'm doing something wrong somewhere. Okay, so we'll connect this up. So our next setup will be where we'll have this device. We'll connect. I will keep this device online in the full class next time. So what we'll do is we'll connect this device to the cloud, and we'll connect it to the local network, and then we'll connect it to the cloud. So actually here in this message part, if you see here, the message should come. This temperature should come here. So it's not coming. I don't know. Maybe some data corruption is happening or something. I have to go through this once. Okay. So I will keep it ready like that so that you can see this data here, because my plan today was only to show you the temperature and humidity. We had time. So I went to this. So we'll showcase this one where we'll see the messages live. So this actually, this client, you will be also, I will share this URL with you next time, so that you can directly go to this and type the select the proper free this one, and you can see the messages yourself, which I am sending from my device here. Okay. After this, what we'll do is we'll create in place of this device, which is real data from the sensor. We will do a mimic of this data only using Python. So our temperature, we will set some random range in which the temperature will be changed, and it will be published. So it will just, for a broker or for a subscriber, it will just look like a real thing. It will not understand that it is from a real sensor or it is a dummy thing. So we'll create a few sensors like that, devices like that, and also the subscribe ones as well as publish ones. And around that, we'll start creating, we'll do a emulation or a VM setup for Raspberry Pi. In the Raspberry Pi, we'll create a broker like this. This is a public broker. This test client cloud.mqtt.cool, which we are seeing here. This is a free broker which is installed in the server. We will install one broker inside the Raspberry Pi VM, so that becomes a local gateway. Now these all sensors, which are dummy sensors, which will be running on your system itself in the same network, so it will connect to that gateway. Okay, and your system will create a cloud-like setup. So there will be three components. These Python codes which will be running like dummy devices. Then we'll have the Raspberry Pi VM running as a gateway, and your system behaving like a cloud. All will be in the local host setup, but you will get the architectural level scenario for all the three things. Okay. Clear, everyone? Anyone wants to add? Sorry, guys, I was not able to show you the real data coming to the cloud today because I didn't checked out the code before, because it was not part for today. But no issues. First thing, I will keep this setup ready. We'll start and we'll just do this publish, subscribe, and then we'll move ahead with other things. Okay. In the meantime, you can go through the code link which I have sent, where you can check out these the code structure and understand it. Okay. Anyone wants to give comment? Yes, no, anything? Model 3B, what setup should I do, sir? You do simple as Raspberry OS, you keep it ready. I will give instructions parallelly. Whoever has a Raspberry Pi itself, he can directly use the real Raspberry Pi. You should know how to get to the terminal of it. Okay, Sanjay, you can get your Raspberry Pi, no issues. You just have to get to the terminal. Yeah, SHS mode is required. So if it is a virtual one, it's a real one, doesn't matter. Anyone else? Any doubts you have? In the meantime, I will just check out if I can do this, if I can see something, some issue here. It's already nothing, sir. Anyone else? Any questions you want to ask me? Any questions? Anyone? Okay, I think we can stop the class today. First thing, next time we'll see this one. I'm not sure, because maybe this These are public this ones. Now I have to also check that this public broker is working or not. I just selected a random broker, but I have to check out that this broker actually works or not. Or just a second, just hold on a second, guys. I will just run one of my codes, which I will be having to see if this is working properly or not. Just a second. Huh? Just give me a sec. I can show you this test. Just a second. I have this as a broker. So let me see. This kind of code you will be doing next time. So I'm just doing a subscribe of the same topic. C minus under bar sensor. Okay, and my this one is test dot muscle.org. Okay. Let us see this works or not. Let me open a terminal. Let's run Python 3 sub.py. It is not coming. I think the mosquito is not. No, mosquito is working. Maybe some issue with the mosquito here. So it was a second. So this is working properly. No, maybe the broker only is not working. I will check out the best broker which you can get, and from there we'll work it around. Okay. Okay, everyone. Bye. Tomorrow we'll meet at 6. We'll start with the sensor demo properly, where you will get the data as well as you will get the data on the cloud. I will give you the cloud link as well as the data showcasing. Okay. Okay, Amar, I think we can stop the session now. Anything you want to add?
No, nothing.
Okay.
Yeah, sure. Thank you so much, guys. We'll meet you on tomorrow at same time. And sorry for the late, I think. No problem. It's 8 minutes only.
Yeah. Sorry.